Hello everyone, welcome to Foundations of Math. My name is Brittany Depew and I will be your teacher for this summer semester course. Today we're going to go ahead and get started in chapter 0 in your books. This first test will be covering sections point 1 and point 2, and then the following week your next test will be over sections point 3 and point 4, and then we'll be getting started into chapter 1. Okay? Alright, so this chapter point 1 is called Factors and Simplifying Fractions. So these first couple sections will be just reviewing skills that you should already know. Okay? Alright, so the first thing we need to cover is a prime number. So we know that a prime number is a whole number that is divisible by only 1 and itself. Okay, so prime number is a whole number that is divisible by only 1 and itself. So examples of prime numbers include 2, 3, 5, 7, 11, 13, 17, and so on and so forth. Okay, so these numbers I can only come up with the whole number 2 and 1. 2 times 1 is 2, right? 3 times 1 is 3. Same thing if I divided it. 2 divided by 1 is 2, and that's the only way that I can divide that, okay? All right, so now we need to go ahead and talk about composite numbers. Composite numbers. So if this is numbers that are only divisible by 1 and itself, composite numbers is everything else, okay? So this is a whole number that is divisible by more than 1 and itself, okay? So composite numbers are whole numbers that are divisible by more than 1 and itself. So examples of composite numbers would be 4, 6, 8, 9, 10, 12, 14, 15, so on and so forth, right? I can divide 4 by 4, 1, I can divide it by 2, right? 6, I can divide it by 6, by 1, by 2, by 3, and so on and so forth. Okay, so that's the difference between a prime number and a composite number. So you're going to be asked to classify numbers to see if they're prime or if they're composite. Okay, it's the first thing they're going to ask you to do. And by the way, all of this that I'm writing on the board is in the PDF of the notes, okay? So if you can't read something that I've written on the board or you need to look at it again, right, it is in the notes, okay? So we want to know, are these numbers prime or composite, okay? Prime or composite. So let's look at the number 37. Can I divide any number into 37 besides 1 in itself, 1 in 37? So, knowing what we know about numbers, nothing else goes into 37. So 37 is prime. Okay, 37 is prime. Let's go ahead and look at 39. Is 39 prime or composite, right? Can anything go into 39 besides 1 and 39? If we remember what we know about numbers, there is another number that goes into 39, right? It's divisible by 3. So this is composite, okay? This is a composite number. 3 goes into 39. All right, let's look at 51. Is 51 prime or composite? Is it divisible by anything besides 1 and 51? It is, okay? It is divisible by 3. So this is a composite number. And then we have, let's look at 59. Does any number divide into 59 evenly besides 1 and 59? And it does not. So this is a prime number. So this is the first thing they're going to ask you to do, okay? So let's say you're unsure of where to start with this, and you can't exactly remember the rules for numbers. So we know that a number is divisible by 2 if it ends in an even number. Okay, it ends in an even number. So that would be 0, 2, 4, 6, 8. If that number ends in 0, 2, 4, 6, or 8, it can be divisible by 2. Okay, so it's a great place to start. Let's say we know that a number is divisible by 5 if that number ends in 0 or 5. Okay, so if that number ends in a 0 or 5, it's divisible by 5. Now, there's a trick to know that a number is divisible by 3. Okay, so that's how I knew that 51 was composite, and the same with 39, that I knew was composite, and both of these numbers were divisible by 3, okay, is by using this trick. You are going to add all the digits and then divide by 3, because this should be a much smaller number and something that you would know automatically that's divisible by 3. So for example, let's look at 51. You would add the digits 5 plus 1. Well, 5 plus 1 is 6. Is 6 divisible by 3? Yes, gives you 2. So it's a composite number, right, and it's divisible by 3. Same thing with 39, right? 3 plus 9 gives us 12. Is 12 divisible by 3? Yeah. It's divisible by 3, gives me 4. So yeah, that's a composite number and it's divisible by 3. So those are just a couple tricks to get you kind of started with that. If you're not exactly sure, to check if this is prime or composite. I don't have any really good tricks for 7. You have calculators, right? You're more than welcome to use those. So you can always just punch in the number, hit divide by 7, and see if that works. Okay? All right, the next thing that we are going to cover is writing the number as a product of prime factors. Okay? So we are now writing a number as a product of prime factors. Okay? We're writing numbers as a product of prime factors. So you might have done this before in other classes and in high school, and you may have done factor trees, okay, where you start getting all the branches and you keep branching out, and it can get really confusing really quick. And sometimes we accidentally write some of those branches down multiple times, or we forget to write down a branch. So I do it a little differently. You're still technically branching, you're still technically doing the same thing, but it organizes it a little bit better. So let's go ahead and look at the number 90. We want to write it as a product of prime factors. The first step that I would do is I would say, okay, what number goes into 90? It doesn't matter what number goes into 90, right? I just want any two numbers multiply together to give me 90. And you can do this multiple ways, right? You could do 9 times 10, you could do 2 times 45, right? There's various avenues that you could go. So let's just say that's divisible by 2, right? Ends in an even number. So let's go ahead and do 2 times 45, okay? So now we're going to break this down. Is 2 a prime number, hence the prime factors, right? So is 2 a prime number? Yes, 2 is prime, right? It's only divisible by 1 and itself. So we're going to do another equal sign, and we're going to bring down that 2 and our multiplication symbol. Now we're going to look at the number 45. Is 45 prime? No, it's a composite number, right? Several different things that go into 45. So we're going to break this down. And 45, any two numbers to come up with 45. So let's go ahead and do 5 times 9. So like I said, it's similar to that factor tree, but it's just organizing it a little bit better. Okay, so we're going to go ahead and keep continuing. 2, right? We already said it's prime, so we're going to bring the 2 down. Now we're going to look at the 5. Is 5 prime? Yes. The only numbers that go into 5 is 1 in itself, so we're going to bring down the 5. Now we're going to go ahead and look at the 9. Is 9 a prime number? No. 3 goes into both. Or 3 goes into 2 times, I'm sorry. So 3 times 3 gives us 9. So then we're going to look at our answer. Are all of those numbers prime? And we look at 2, 5, 3, and 3. Those are all prime. So this is our answer. Now you can leave it like this. That's fine by me. The book shows it as well by using exponents. That's fine by me also. So you could write your answer as 2 times 3 squared times 5. That's fine. Or like I said, you can leave it this way. It doesn't matter to me either way. It's the same thing. Okay, let's look at another one. Let's do 120. Okay, let's do a large one. So let's say we're not sure where to start, but I look at that number and I know, hey, that's divisible by 10. Okay, so right, I want any two numbers that multiply together to give me 120. And I want to do 10 and 12. Okay, so now we're going to analyze each number. Okay, so first we're going to go ahead and look at 10. Is 10 a prime number? Nope, it's not. I can break 10 down into 2 times 5, okay? Now I'm going to go ahead and analyze 12, right? There's multiple ways that you can come up with 12, right? 2 times 6, 4 times 3, doesn't matter either way. It's just any two numbers that give me 12 when you multiply them together. So let's go ahead and do the 4 times the 3, okay? We're going to come down to our next line. Let's analyze 2. Is 2 a prime number? Yes. Let's go ahead and bring it down. Times 5. Is 5 a prime number? Yes. So we're going to go ahead and bring that down. Times. Now we're going to analyze the 4. 4 is not prime, it's composite. So now we need to break that down into 2 times 2 gives us 4. And then we're going to go ahead and look at our 3, and 3 is a prime number. Okay, so then we're going to look at our answer. 2 is prime, 5 is prime, 2 and 2 is prime, and 3 is prime as well. So we are done. That is your answer. Or if you want to write it with exponents, this would be 2 cubed times 3 times 5. And like I said, either answer is fine by me. It means the exact same thing. Okay, so I hope this is kind of making some sense. This product of prime factors, you'll have to do this on your homework and on the test. Okay, this will be on the test as well. Okay, we're going to go ahead and move on. There's 2 more examples of this in the notes, and if you continue to need help with this, please send me a message. I can send you further explanation of how to do this, okay? All right, so now we're talking about fractions. We are getting into fractions, okay, the dreaded fractions. So we know that a fraction essentially is a part of a whole, okay? A fraction's a part of a whole. And we have some terminology that we're going to be using with fractions. So I am not going to say, you know, the top of the fraction, the bottom of the fraction, right? I'm going to actually be using the correct mathematical terms. So you do need to make sure that you are comfortable using these terms. So let's say we had a fraction of 3/5. The top number, the 3, is called the numerator. And this is over. The bottom number, the 5, is called the denominator, okay? So top number is numerator, bottom number is the denominator, okay? Now, fraction problems are essentially division problems. This is something that you'll need to know later on, okay? But it's something to be aware of. Fraction problems are essentially division problems. Has this big bar signifying division. But like I said, we'll get more into that later, okay? Another term you need to know is what is known as a proper fraction. A proper fraction. This is when the numerator is less than the denominator. Okay, so this is what we would know as a typical fraction. When we think of fractions, we're going to think of a proper fraction. So, for example, this is something like 1/2. The 3/5 we just did on here. 5/6, right? Those are all proper fractions. Okay, those are proper fractions. Another type of fraction that you need to know is what is called an improper fraction. So we had proper, now we have improper fractions. Sorry guys, I write terrible. I have terrible handwriting, so bear with me. All right, improper fraction. Improper fraction. So this is when the numerator is greater than the denominator, okay? So this is the opposite of a proper fraction. So for example, this would be something like 5 over 3, 8/3, 3 over 2. Also, 5 over 1, which you've simplified, would be a whole number 5. So a whole number you can turn into an improper fraction by placing it over 1. Okay, so that's improper fractions. We're going to be getting into more of those later. The next thing this section asks for you to know is how to reduce fractions. So we're going to be reducing fractions. So this is something that hopefully you've done before, and like I said, hopefully this is just a refresher, okay? So if we were to look at the fraction 2/8, right? We always reduce fractions as much as we can, unless it specifies not to, which is very rare, okay? Usually we always want the simplest answer when we're dealing with fractions. So we have 2 over 8. Our goal is to see if there is a common factor that we can remove from 2 and 8. So basically, we want a common number that we can divide into both, okay? Into both the numerator and the denominator. So is there a number that's divisible into 2 and also divisible into 8? Yes, 2. Both are divisible by 2. And it has to be the same number, the same factor, okay, that we can divide out. So 2 divided by 2 is 1. 8 divided by 2 is 4. So 1 over 4 is our final answer, right? Nothing goes into 1 and 4 except 1, which doesn't change our answer, okay? Let's look at another. So let's look at 3 over 15. So is there a number that divides into 3 and also 15? So if we use our rules before, right, 3 is divisible by 3, but let's look at 15. 1 plus 5 is 6. Yeah, 6 is divisible by 3. So both the numerator and denominator is divisible by 3. So 3 divided by 3 is 1, and 15 divided by 3 is 5. So 1 over 5 would be your final answer. Always double check yourself just in case. Nothing goes into 1 and 5 except for 1, so we're good, and that is our final answer, okay? Let's do just a couple more of those. Okay, let's look at ten over 70. 10 over 70. So there is a trick when reducing, when they both end in a 0. So if they both end in a 0, they have to end in the 0. You can cancel those out because they're both divisible by 10. So the zeros cancel and you are left with 1 over 7. Okay, let's go ahead and look at 10 over 200. They both end in a 0, so we can cancel those zeros, and we're left with 1 over 20. So you can only cancel a pair, okay, from the numerator to the denominator. You can only cancel a pair. So 1 over 20 would be your answer here, okay? Let's say they gave you 9 over 27. 9 over 27. And let's say you weren't exactly sure where to start, but you knew that both the numerator and denominator are divisible by 3, okay? And let's say you weren't sure that it was divisible by 9, that's okay. And let's say you started with a 3. So 9 divided by 3 is 3. 27 divided by 3 is 9. And then we're going to look at our answer again and double check ourselves. Well, does anything go into 3 and 9? Oh yeah, it goes one more time, right? 3 goes into both the numerator and the denominator. So 3 divided by 3 is 1, and 9 divided by 3 is 3. So 1/3 would be your final answer. So that's why I say it's important to double check your answer, because let's say you weren't sure, you started with a low number, and then you realized, hey, this goes one more step. That's fine. Take that extra step to get the final answer. All right, now let's say they gave you 8/0. So remember a little bit ago how I talked about fraction problems are essentially division problems? They are. This is the same thing as saying 8 divided by 0. 8 divided by 0. We can never divide by 0. So if you see a fraction like this with a 0 in the denominator, your answer is called undefined. We'll be using that term all throughout the semester, okay? Undefined. 8 divided by 0 can't happen, okay? So this is called undefined. All right, these fraction sections are long, okay? Bear with me. So the next part in this section, point 1, we're still in point 1, we are going to be building equivalent fractions. Building equivalent fractions, okay? So this is something we're going to have to do when we are dealing with addition and subtraction with fractions. So we need to become familiar with how to do this. So they're going to tell you to write the fraction 3/4 as an equivalent fraction with a denominator of 20, okay? We're going to be learning what I call 2 circle methods in this class. This is going to be the first circle method you're going to use, and you need to make sure that you study the difference between the 2 circle methods because they do 2 completely different things. So this is the first circle method. What you're going to do is you're going to take your original fraction, 3/4, and set it equal to, we're going to have another fraction, and they're giving us the denominator. They said we want the denominator to be 20. So we're going to put that in the bottom, right? It's a denominator. So we're solving for the numerator, okay? And some of you may already know another way to do this, and that's fine. Do whatever way works for you. If you're unsure, stick with this circle method. So basically, the circle method, you're going to be coming full circle, okay? And you're going to be moving in the left direction, okay? So the first thing that you're going to do is divide. So you are dividing 20 divided by 4. Well, 20 divided by 4 is 5, okay? Then you are going to be multiplying by the numerator times 3. So you're dividing the new denominator by the old denominator. 20 divided by 4 is 5. Then you're going to be multiplying by the numerator, which is 3, to give us 15, okay? So your answer would be 15/20. Because you're building an equivalent fraction, you are not reducing, okay? Do not reduce this. You end up with 3/4 where we started at the very beginning. That's not what we want to do. So when you're building equivalent fractions, do not reduce, okay? All right, let's do another one. So let's see, this time our fraction's gonna be 5/6, and our denominator is gonna be 54, okay? So 5/6, we want a denominator of 54. So start with the fraction they gave you. They gave you 5/6, set it equal to, we're gonna start plugging into another fraction, and they said the denominator is going to be 54, okay? So we're solving for that numerator, okay? So once again, here's our circle method. We're going in the left direction. The first thing we're going to be doing is division. So you're going to do 54 divided by 6 gives us 9. Then you're going to do 9 times 5 gives us 45 over, 54. So 45 over 54. So what I like about the circle methods, once you get used to it, you can do it in your head, you can do it mentally and not have to write it out like I did on that very first problem. But if you need to write the workout, by all means, go ahead and write that workout, okay? All right, let's look at one more of those. These are going to be very important later on, so you do want to make sure that you practice this method. So let's look at 9 over 13 with a denominator of, that's a 7, 78. Okay, so 9/13 with a denominator of 78. So once again, we're going to start with our 9 over 13. Set it equal to, I'm not sure yet, over 78. And we're going to do our circle method in the left direction, and we know we're going to be dividing first. So we're doing 78 divided by 13 gives us 6. 6 times 9 gives us 54. So 54 over 78 is our answer there. Okay, that's our answer. All right, so we're moving on. But like I said, you need more help, please let me know. Okay, I'm more than happy to help you out with this. All right, let's continue. So these first two sections are really heavy with nothing but fractions, so they're very long. The other sections that we do in this book are not quite as long, so please bear with me with this first couple sections. Another thing they want you to know how to do is reducing using prime factors. So this is another way to reduce fractions. I typically don't do this a whole lot. I use the other method, but whatever works for you is fine by me. You're not tested on this, but I do want to show you one problem in case you see it in the book. Okay, so let's say they want us to reduce 15 over 30, and they want us to use prime factors to do that. So we're going to break down 15 into prime factors, just like we did before in the very beginning of this section. So any two numbers that multiply together to give me 15, well, I know that 3 times 5 gives us 15, okay? And both of those are prime, right? 3 is prime, 5 is prime. We're done with the numerator. So let's go ahead and look at 30, okay? We need to look at 30. And you may want to do this one on the side. So any two numbers to give us 30. So you could do 6 times 5. You could do, 2 times 15. It doesn't matter either way, okay? You're going to get the same answer. So we're going to look at the 2. 2's prime. We're going to write it down, and we're going to analyze our 15. 15 we can break up into 3 times 5, and all of those are prime. So we're going to go ahead and put that in our denominator. Because 2 times 3 times 5 is 30. So it's a good way to check your work, right? Multiply those numbers together, and you should still end up with your original number, okay? All right, so now that we did this, we are going to cancel pairs of numbers from the numerator to the denominator, okay? It has to be a pair, and it has to be from the numerator to denominator. It can't be all in the denominator. It can't be all in the numerator. It has to be from top to bottom. So here, I have 2 3s, so those can cancel. I also have 2 5s, those cancel. And then we're going to go ahead and write our answer with what's left. So there's nothing else in the numerator, but it's a fraction, so we're left with the whole number 1, and in the denominator we're left with a 2, so that became 1/2. So that's another way you can reduce fractions. You don't have to use this method, but you're more than welcome to if you would like, but you're not going to be tested on that, okay? All right, the last thing in this section to prep us for section point 2 is dealing with least common multiples. Least common multiples, you might remember seeing these as LCMs. Okay, you'll see that in the book as well. So least common multiple, LCM. So this is the smallest number that is divisible by each number, okay? So this is the smallest number that is divisible by each number. So we'll do some examples so this makes sense. So we want to look at common multiple, least common multiple for 4 and 8. 4 and 8. So let's go ahead and analyze the 4 first. So all you're going to do is come up with a times table, basically. So you're going to do 4 times 1. Well, 4 times 1 is 4. Well, what's 4 times 2? 4 times 2 is 8. What's 4 times 3? 4 times 3 is 12. And you see it just continues on, okay? Or you could just, add 4 over and over again, right? It's essentially doing the exact same thing as the multiplication. And you're going to do the exact same thing for 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24, right? So on and so forth. Your goal is to find the smallest number, the smallest multiple that they have in common. So do you see anything they have in common? They do, right? It's 8. So the LCM, the least common multiple for 4 and 8 would be 8. Okay, so some of these you can look at and probably spout off right away. Some of the other ones, right, we may have to work out. So let's do just a few more examples of this so that you're ready for the next section when we deal with least common denominators. Okay, let's go ahead and look at, I have several examples in your notes. Let's just do a couple of them. Let's do 27 and 9. So let's go ahead and analyze 27. Well, 27 times 1, right? 27. We may want to stop there to see what's going on with the 9. So let's go ahead and look at the 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Well, I can stop, right? Because they both have 27 in common, right? That's the smallest. So your LCM, your least common multiple, would be 27, okay? Sometimes they'll give you 3 numbers instead of 2, and that's okay. That can happen, not a big deal. And we can handle this. So let's go ahead and do one. Let's do 12, 24, and 36. And like I said, there's a couple more examples like this in your notes if you need to see some more examples. So let's look at 12, 24, and 36. So we'll start with 12. Okay, we'll start with 12. So we have 12 times 1 gives us 12, right? Then we would end up with 24, 36, 48, 60. It's a bad 0, sorry guys. 60, 72, 84, right? And it goes on forever, right? We don't know where to quite stop yet. So let's go ahead and look at the number 24, and let's start writing those multiples out. So I have 24, 48, 72, 96, so on and so forth. And last, let's look at 36. So 36 times 1 is 36, times 2 is 72, times 3 is 108, right, and so on and so forth. So we see that 12 and 24 have 24 in common, right? But 36 isn't in there. So it has to be a number that all 3 of them have in common. So if you notice, all 3 have, I can't write tonight, guys, sorry. All 3 have in common least common multiple of 72, okay? So like I said, that's something else you have to do for this section, and we're going to be doing this more in section point 2, okay, when we get into least common denominators. So if you ever have any questions, please do not hesitate to message me either by text or by email, right? Hopefully you've read the newsletter. The welcome letter that I made has all that information in it. Please, please, please message me if you need me, okay? All right, see you guys.